friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your chemistry for class 11 part 2, where we had done your part 1 there in the last unit, and this is being your class 8, where we had done for part 2, this is your class 8, and we had done your 7 classes where we had completely started with your unit 8 Redox section. Hopefully if it has not been exceeded, so yes, it will be ended up, unit 8 will be ending it up in this class only. So lastly, what we had done is your redox reaction as a basis of the titrations, where the limitations and the concepts of oxidation number. Today we'll discuss about the redox reactions and the electrode processes. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So here we go. Redox reaction and electrode processes. So in the same way we talk here in the detail. The experiment that corresponding to the reaction that can also be observed if zinc rod is dipped in copper sulfate solution, where the redox reaction takes place, and during the reaction zinc is oxidized to zinc ion and copper ions are reduced to metallic copper due to the direct transfer of electron from zinc to copper ion. During this reaction, heat is evolved here. Now we modify the experiment in such a manner that for the same redox reaction, we transfer the electron takes place indirectly, and this necessitates the separations of zinc metal from copper sulfate solution. We take copper sulfate solution in a beaker and put a copper strip on the rod in it. We also take zinc sulfate solutions in the another beaker and put the zinc rod on a strip in it, and now the reaction takes place in either of the beakers and at the interface of the metal, and if and it's a salt solution in each beaker. Both the reduced and oxidized form of the same species are present, and these represent the species in the reduction and oxidation half reaction. A redox couple is defined as having together the oxidized and the reduced form of substance taking part in the oxidation and reduction half reaction. This is represented by separating the oxidized form from the reducing form by the vertical line or a slash representing by an interface. Example like solid solution, and for example in an experiment that the two redox couples are represented as zinc 2 plus by zinc and Cu 2 plus by Cu. In both cases, oxidized form is put before the reduced form. Now we put the beaker containing copper sulfate solution and the beaker containing zinc sulfate solution side by side. We connect solutions in the two beaker by salt bridge, and that is a U-tube containing solutions of potassium chloride or ammonium nitrate, and usually solidifies by boiling with agar and later cooling to that jelly-like substance. This provides an electric contact between the two solutions without allowing them to mix with each other, and the zinc and copper rod are connected by a metallic wire with the provisions for an ammeter and a switch to set up, as shown, that we'll discuss here as a Daniell cell. And when the switch is in the off positions, no reactions takes place in either in the beaker and no current flows through the metallic wire. As soon as the switch is in on position, we make the following observation. But before making a following observation, we'll just draw the diagram here first, then we'll see the observations here. So we go for it for the oxidation and reduction one. So current flow in the direction this, and electron flow direction in this. This is your switch, this is cathode, this is anode, this is a salt bridge. Okay, this is oxidation, this is reduction. In terms of oxidation, we talk here, that is being your zinc, Zn2 plus 2 electron. For reduction, it will be Cu2 plus 2 electron will give Cu2. So for the same, that the setup for the Daniell cell, the electron produced on the anode due to the oxidation of zinc travels through the external circuit and to the cathode, where these reduced inside the cell by the migrations of an ion through the salt bridge. It may be noted that the directions of the current is opposite to the direction of electron flow. The observations that we see through this is what it will be. It is being like the observation that we can see, as you also can see with a very clear manner, that the transfer of electron now does not take place directly from zinc to Cu2 plus, but through the metallic wire connecting the two rods, as it's apparent from the arrow, which indicates the flow of current. The electricity, the second what the observation we see here is the electricity from the solution in one beaker to solution in the other beaker flows by the migrations of ions through the salt bridge, and we know that the flow of the current is possible only if there is a potential difference between the copper and zinc rod, known as electrode here, where the potential associated with each electrode is known as electrode potential. If the concentrations of each species taking a part in the electrode reaction is unity, if any gas appears in the electrode reaction, it is confined to 1 atmospheric pressure, and further the reaction is carried out at 298 Kelvin, then the potential of each electrode is said to be a standard electrode potential. By convention, the standard electrode potential of hydrogen electrode is 0.00 volt. The electrode potential value for each electrode process is a measure of the relative tendency of the active species in the process to remain in the oxidized and reduced form. A negative means that the redox couple is a stronger reducing agent than the H plus and H2 couple, where a positive EMI means that the redox couple is a weaker reducing agent than the H plus and H2 couples. With the standard electrode potentials are very important, as we can get a lot of other useful information from them. The values of standard electrode potential for some selected electrode processes, reduction reaction, that are given in the table. You will learn from more all these cells in the next coming classes, which is we'll discuss for the 12th one as well. So now here we made it, that is the standard electrode potentials at 298 Kelvin. So we go for the same. The table we made it, the standard electrode potentials at 298 Kelvin, where the ions are present in the aqueous solution, and H2O as liquid, gases and solids are shown by the G and S respectively. Again, so for the same we go here and we'll find it out as well. So on the same way, we have here the reaction oxidized from form A plus Ne minus, and then of course the reduced form, and then E by V form. So we just write it down here so that you will get to know. So here, this is your reaction, oxidized form plus any will give you reduced form, and then your E by V. Okay, so this is how you have to do it, and let's find out for the same. So the first reaction we talk here, this is your F2 gas plus 2E minus, which will give you the reduced form here, which is 2F minus, and this is your 2.87. The another equation is CO3 plus electron will give you CO2 plus, this is 1.81. You can just write it down one by one so that you will be able to as well know. So now we talk about for the next one, that is the third one, which is H2O2 plus 2H plus 2 electron, that will give CO2 2H2O. So this is 1.78. Another which we have here, MnO4 minus plus 8H plus 5 electron, it will give you Mn2 plus 4H2O. This is 1.51. Another which we have is your Au3 plus 3 electron minus, that will be having Au, which will be 1.40. The another we have Cl2 gas plus 2 electron, which will give you 2Cl minus, which is 1.36. Another is Cr2O72 minus plus 14H plus 6 electron. It will give you 2Cr3 plus 7H2O, which will be 1.33. Another is O2 with the form of gas plus 4H plus 4 electron will give you 2H2O, and that is 1.23. Now we go for it, another one, MnO2 solid plus 4H plus 2 electron. It will give Mn2 plus 2H2O, which will give 1.23. The another is Br2 plus 2 electron. So with the same we go for it, and that's what we'll have to answer it out here as well. So here in the same way, Br, that is your 2E, which will give you 2Br, that is 2Br minus, and which is 1.09. Now we go for the another one which we have here, which is NO3 minus plus 4H plus 3A. It will give you NO in the form of gas plus 2H2O. it will be 0.97. The another we have here is 2Hg2 plus 2 electron, which will give you Hg2 2 plus, and that is 0.92. Now we have another one, which is Ag plus electron. So that is, we have your Ag in solid state, and which is your that we have the tendency which we have here is 0.80. Now for the another one, which is Fe3 plus electron, it will give you Fe2 plus, and that we have here is 0.77. The another we have here is O2 in the form of gas plus 2H plus 2 electron, that will give you H2O2, and that is we have 0.68. Another we have here is I2 in solid plus 2 electron. So the next we have here, which is your I2 in the form of solid, and that will be in solid and plus 2 electron. It will give you 2I, and that is 0.54. The another we have here is Cu plus electron, that is give you Cu in the form of solid, and that is we have here, and that is 0.52. The another we have here Cu2 plus 2 electron, it will give you Cu in the form of solid, but here that in this change is your 0.34. Next is your AgCl in the form of solid plus electron, it will give you Ag in solid plus Cl minus. The tendency is 0.22. The another we have here is AgBr, solid plus electron, that will give Ag in solid plus Br minus, and the tendency we have 0.10. The another we have here, that is your, after AgBr it is 2H plus 2 electron, will give you H2 in the form of gas. The tendency is 0 here, 0.00. The another we have, now we will be having a negative because this is all coming toward positive. Now it is 0, and then it will go to the negative one. Bp2 plus 2 electron will give Pb as minus 0.13. The another we have Sn2 plus 2 electron, that will give Sn in the form of solid, it is minus 0.14. Now we have another one, Ni2 plus 2 electron, So this is Ni, sorry, which is minus 0.25. Another is Fe 2 plus 2 electron, which is Fe solid minus 0.44. Now we have another one, Cr 3 plus 3 electron. It will give Cr, and that we have, but it is not visible. So now it will be Cr 3 plus Cr is that we have here, and the tendency is minus 0.74. Another we have here is Zn 2 plus 2 electron will give Zns, and the tendency we have minus 0.76 that we have. Now we talk about for 2H2O plus 2 electron, that will give H2 gas plus 2OH minus, and the tendency we have minus 0.83. The another we have here is your, so here that is your An 3 plus 3E, which will give you An in solid, and the tendency that is it will be minus 1.66. The another we have here is your Mg 2 plus 2 electron. It will give you Mg in solid, and that is minus 2.36. Another is your Na plus electron, which is will give you Na solid minus 2.71. Another is Ca2 plus 2 electron. It will give you Ca in solid, and minus 2.87. The another we have is your K plus electron. It will give you K in solid minus 2.93. The another for the lithium ion, so I just write it down here only. Lithium plus electron, it will give you lithium in solid, and that tendency is minus 3.05. Okay, so this is here a negative E, that means in the redox couple is stronger reducing agent than the H plus by H2 couples, and in the same way we talk here. So a positive E, that means that the redox couple is a weaker reducing agent than H plus by H2, that couple we have. Other than that, if I'm going to put the tendency here, so here in this increasing strength of oxidizing agent, in this manner it is, in this manner, in the upward manner, it is increasing strength of oxidizing agent, increasing strength of oxidizing agent in a way. Okay, from down to up, from up to down, what it is, increasing strength of reducing agent, increasing strength of reducing agent from up to down. Okay, so that's what you have to know about it. Now coming towards further, there were some things that we have to discuss about in terms of it. So here we go for it, and then we have your questions related to it as well. So in the redox reaction that form an important class of reaction in which the oxidation and reductions occur simultaneously. The three-tier conceptualization, that is your classical electronic and oxidation number, which is usually available in the text, has been presented in detail. And oxidation, reduction, and oxidizing agent, which is your oxidant, and reducing agent, that is reductant, have been viewed according to each conceptualization. Oxidation number is then assigned to the accordance with the consistent set of rules. And oxidizing number and ion electron method, both are useful means in writing equation for the redox reaction. Redox reactions are classified into four categories, that is combination, decomposition, displacement, and proportion reaction. The concept of redox coupled electrode process is introduced here, and the redox reaction find wide application in the study of electrode process and the cell as well. Coming towards some of the questions related to it, where that we have, that what even though we have to discuss about in the detail here. So there were the questions, many more than it's approximately it is up to 30 that we have to discuss here. So we're gonna discuss that as well soon. So that is in the next coming class because it will be exceeding. So we go ahead and that will continue surely for that. So surely that we'll discuss in the 9th class of the session. So here before ending it up, as I told you that we are dealing with the physics one, which is of class 11th, part 1 we had started with, and which is we had done your physical world, that is unit 1, and unit 2 which we had started with, that is units and measurement, and surely we'll be ending it up in this class. The next coming class will be uploaded. Coming towards your quantitative aptitude, in that we had done arithmetical ability, in that we had in 15th topic, 14th topic we had completed. And in terms of reasoning, we had done your verbal reasoning and non-verbal reasoning. Coming towards CBNST, we had done in terms of database management system, we are dealing with the ER diagrams, we are dealing with English vocabulary, as well as coming towards your chemistry. So yes, in part 1 we had done unit 1 some basic concepts of chemistry, unit 2 is structures of atom, unit 3 classification of elements and periodicity in properties, unit 4 is chemical bonding and molecular structure, unit 5 is the states of matter, unit 6 is thermodynamics, unit 7 is equilibrium. That all 7 units we had done. And in terms of it, unit 8 that we are dealing here is the redox reaction. Here we had done classical idea of redox reaction, oxidation and reduction reaction. We had done a redox reaction in terms of electron transfer reaction. In that third topic we had done your oxidation number and redox reaction and electrode processes that we had done. The left one is your only the questions, so that after completing that we'll be ending it up with the unit. Then we'll start with hydrogen, that we'll discuss. Then unit 10 is your S block element, unit 11 is your P block element, your unit 12 is your organic chemistry, some basic principles and technique, unit 13 is your hydrocarbons, unit 14 is your environmental chemistry as well. So that what we'll have to do. So before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on comment box. Thank you.